Yaskawa.
Welcome to Yaskawa Electric America's e-learning module for the J1000 drives, features, and benefits. Hello, my name is Chris Amick, and I am an engineer in the Technical Training Department at Yaskawa Electric America. I will be your instructor today as we go through this e-learning module. Yaskawa has started a new generation of microdrives with the V1000. The J1000 is our second offering, which improves upon the J7. The main focus of the engineers at Yaskawa was to double the life of their already robust microdrive, the J7. Assuming the J1000 is properly sized and installed, and operating at 40 degrees Celsius ambient temperature, and driving a consistent load not exceeding 80% of drive-rated current, the J1000 will probably last as much as 10 years or more. To achieve such performance, even the normal wear items of a drive, such as cooling fans and bus capacitors, were designed to a tougher standard. Also, circuit boards are interconnected using a solderless joint design, which test proof increased the drive's vibration tolerance from 20 to 50 Hz. To improve quality even further, a complete revision of Yaskawa drive production lines has taken place, and human error has been reduced by installing the most advanced robotic technology available. A good way to extend the life of drive components is to reduce the heat that they are subjected to. Yaskawa Drive's engineers utilized a special thermal simulation program to help them optimize the locations of certain components and improve airflow within the drive. The diagrams shown here detail how the maximum expected heatsink temperature was reduced by 7 degrees Celsius by just rearranging select components. The next step in reducing the heat within the drive is to make the heatsink cooling more efficient. Yaskawa drives utilize a heatsink design that promotes air turbulence while the air flows over the heatsink. The turbulence allows the cooling air to spend more time in contact with the fins. This keeps the drive cooler. The design also incorporates features that promote the chimney effect, which has been proven to increase convectional cooling for electronics. Yaskawa engineers strove to simplify the construction of the J1000. The number of mechanical parts in the J1000 was reduced by up to 35% over the J7 drive and by over 50% when compared to the comparable larger 7th generation Yaskawa drive. The reduction in mechanical parts will improve the expected drive lifetime by reducing the chances of mechanical wear and tear. The J1000 also gave the engineers the chance to reduce building costs by reducing the number of screws used in assembling the drive. The quantity of necessary assembly screws was reduced by up to 54% over the last generation. The J1000's design truly is superior to our already industry-leading microdrive line, partially due to this 50% reduction in mechanical parts in most cases. The reduction in numbers of parts helps us increase our mean time between failure rating and helps us to reduce the chance of parts shortages due to vendor issues. That means Yaskawa will always have the drive you need in stock. For those of us that are familiar with Yaskawa's part numbering system, there is one major change with the new generation. Previous Yaskawa part numbers included the drive's power rating in the part number. Starting with the V1000, Yaskawa uses the drive's output current rating in the part number in place of the power rating. The current number will correspond to the normal duty output current rating of the drive. Arguably, the most important specifications of the J1000 are the available power ranges and the normal duty and heavy duty current capabilities. I would also like to point out that Yaskawa does offer single-phase J1000s up to 3 horsepower, and that the J1000 can go up to 7.5 horsepower with 3-phase power. As I mentioned before, the J1000 features a dual duty setting. Although you may find this feature in larger, full-function drives, it is uncommon in a microdrive. When set to heavy duty, the drive will allow for 150% of rated current for up to 1 minute, and offer a high carrier frequency for quiet operation. For J1000 models with output current capacities of 1 amp through 6 amps, the carrier frequency defaults to 10 kHz. For models that output 10 amps or 20 amps, the default setting is 8 kHz. If the drive is set for normal duty, the overload is reduced to 120% for 1 minute, but at a higher continuous 100% rating. The carrier frequency will default to 2 kHz and a current D rate will be applied if the carrier is raised above 2 kHz. The effect is that using the normal duty setting will allow the J1000 to adequately power a larger motor than the J7 drive with its single duty setting would be able to. The limitation is the reduced overload capabilities, so knowing the application is a requirement. Let's use an example to illustrate what we just covered. The motor we want to drive is a 230 volt, 3 horsepower motor that will be rotating a fan. The motor's full load current rating is 9.6 amps. If we are going to drive this motor with the J7, it would require using a 3 horsepower model that has a continuous current rating of 11 amps. If, however, we use a J1000, we have the choice of normal or heavy duty. Because this is a fan application, we don't require much overload, so 120% overload will be plenty. Therefore, a 2 horsepower J1000 configured for normal duty will meet the requirements of the motor. It should be noted that the normal duty setting isn't just for fans and pumps, but even for constant torque applications, as long as the overload required doesn't go above 120% of the normal duty current rating. Another exciting feature of the J1000 is the possibility of side-by-side mounting of the drives. Side-by-side mounting means more drives can fit into a smaller space, thus saving money on cabinets and enclosures. Even when the ambient temperature is not optimal, or the output transistors are working harder and faster, producing more heat, tight installations are still possible with a current D rate. Parameter L835 will tell the J1000 whether the installation is indeed a side-by-side installation, and if the protection times need to be shortened. If the ambient temperature can be kept at 40 degrees Celsius or below, and the carrier frequency is acceptable at 2 kHz, then side-by-side operation is possible without any D rate for a drive configured for heavy duty. The minimum separation between J7 drives is 30 mm. That minimum gap has decreased drastically to 2 mm between J1000 drives. The superior thermal design of the J1000 allows the drive to operate in high-temperature applications with little to no D rate. The J1000 arrives from the factory with the open chassis specification. Operation under this spec requires no D rate up to 50 degrees Celsius. Even the NEMA Type 1, a more airflow restrictive specification, only necessitates a 15% D rate at the same temperature. Having a higher ambient temperature capability may translate to a smaller enclosure and maybe a smaller cooling device. The J1000 offers a new variation on motor thermal protection that will help users meet upcoming specifications. Per the National Electric Code, drives will need to go a step further to protect the insulation of motors adequately. The new specification requires that over-temperature protection offers a memory selection that will retain the elapsed I2T thermal protection time, even if the drive is powered down. It is expected that UL will write this same requirement into their next 508C update. Yaskawa will meet the requirement by offering the user the choice whether to hold the I2T value at power down or not, with the factory default state being that the I2T value is held. A downside to some drive installations is the amount of audible noise generated by the motor at low carrier frequencies. Usually, the lower the carrier frequency, the louder the sound. The J1000 offers a new carrier frequency selection that helps reduce the amount of acoustic noise while using lower carrier frequencies. The swing PWM setting sweeps the carrier frequency over a range of frequencies, so the noise is distributed over the whole spectrum. This distribution reduces those peak levels and thus reduces the maximum decibels. The new swing PWM setting is centered around the 2 kHz frequency. It is mainly targeted at drives set for normal duty, since audible noise for a J1000 set for heavy duty can be reduced by using a higher carrier frequency such as 8 kHz. Even for heavy duty, a lower carrier frequency, like the swing PWM selection, may be desirable since a lower carrier frequency means decreased output transistor heating. For examples of a 2 kHz carrier and swing PWM carrier setting. The J1000 will offer a new braking function that is an improvement over the high slip braking used by our last generation drives. The new high flux braking function will be enabled via a parameter but will not require a digital input to initiate. The function manipulates the motor's magnetic field to increase energy loss in the motor and prevent an overvoltage fault while the motor decelerates. The two oscilloscope captures show the contrast between braking with and without high flux braking. The decel time without an overvoltage fault is nearly cut in half, with no extra equipment to purchase like is required with dynamic braking. The amount of braking time that can be cut by high flux braking will be dependent on the motor's characteristics and the application's duty cycles. The most important improvement offered by high flux braking over previous solutions is that reacceleration is possible without coming to a complete stop. To complete our description of the new high flux braking feature, there are a few pieces of information that are important. For one, the stall prevention function is mutually exclusive with high flux braking, so there is a chance that, without proper adjustment, an overvoltage fault can still happen if the decel rate is set too short. Also, because motor losses and consequently motor heating is part of how high flux braking works, it should be noted that the extra heating will not be figured in when calculating the OL1 thermal protection time. It is important that the user be aware that there is a duty cycle limitation to high flux braking that is akin to the limitation of full load across the line starts. For the last few years, Yaskawa has been pursuing RoHS compliance for its products. The V1000 was our first standard product that offered it throughout the capacity range. The J1000 now follows suit. RoHS compliance is an environmental standard that restricts or eliminates certain dangerous metals from being used in products, knowing that later, when the product reaches the end of its life cycle, disposal of the product may have an unwanted environmental impact. RoHS compliance is mandatory throughout Europe and is on the very near horizon in Canada and California. Yaskawa anticipates that it will be the world standard in the years to come. The J1000 will ship standard with a non-removable 5-digit LED keypad. Unlike the J7's keypad, the J1000 keypad will have a shift reset key, making navigation more like the other Yaskawa drives that use LCD keypads. The shift reset key will also function as a reset for drive faults. The optional remote LED keypad requires the optional RS-232C board for use. The design of the J1000 gave the Yaskawa engineers the chance to correct an issue that befell the J7 drive. Though the heatsink fans of all J7s worked just fine, when the time came to replace the older fans at the end of their lifespan, users found that the bottom-mounted fans were hard to get to due to the fact that some of the drive's power wiring was hanging directly in the path of the user's hands as they tried to access the fan. Now with the J1000, all of the heatsink fans are mounted on top of the heatsink for ease of accessibility, yet able to withstand the heat coming off the heatsink. On top of this, fan replacement requires no tools or removal of the drive. This is true for any size J1000. The J1000 offers many improvements over its predecessor. Here is a rundown of some of those improvements since the days of the J7. Some of the improvements are monumental, and some are smaller changes that may actually be just as important to some users. Some of the items listed are functions that one would expect from a more full-featured drive, not a micro drive. Also of note, but maybe hard to understand, is the common control board. In the past, the J7 needed different control boards, one for the larger sizes and one for the smaller sizes. This led to multiple versions of any software written for the drive, which slowed development of custom programming. Separate versions of software is not an issue for the J1000, because it uses a single control board for all sizes and voltages. Monitors in a Yaskawa drive are the drive's way of telling the user the status of the drive operation via the keypad display. The J1000 monitors will seem familiar to users of Yaskawa's 7th generation drives, but with some new twists and new monitors. Most of your basic monitors can be found within the U1 group of parameters, with the new monitor shown here in orange. The U2 monitors will remain the fault trace. The new twist on the fault trace is that a drive parameter initialization will no longer reset it. To clear the fault trace, set 0411 equal to 1. The U4 drive monitors are new to the next generation of Yaskawa drives and are targeted at helping the maintenance person better anticipate drive issues. The user will be able to find out the expected remaining lifetime of 4 of the drive's major wear items, including cooling fans, bus capacitors, soft charge relay, and the output transistors. The expected lifetime will reflect factors such as load, temperature, and carrier frequency, among others. The U4 monitors also include information for operators wishing to find out how hard the drive and motor are working by displaying the heatsink temperature and peak current. Another advanced warning feature of the J1000 is a new high current alarm. If, during operation, the drive outputs more than 150% of drive's rated output current, the keypad will display characters HCA for high current alarm. It is also possible to turn on a digital output in case of any drive alarm, which would include the high current alarm. Because this is only an alarm, drive operation will not be interrupted during the alarm, but high currents can lead to faults which will shut down operation. Therefore, it can be useful to be aware of high current situations that might be remedied by adjusting a parameter. Other Yaskawa drives have offered built-in multi-drop serial communication in the past. This includes the J1000's predecessor. The improvement Yaskawa made was to the transmission speed. We doubled it from the specs of the J7 to 38,400 bits per second. The RS-232C option board will also be available, providing the connection port for the remote keypad, Y-stick, and DriveWizard Plus. As mentioned in the previous slide, the USB copy unit, or Y-stick, needs the RS-232C board for connection to the drive. With the Y-stick, you can save a set of parameters to it and load them into other, similar J1000s. You can also use it as a pass-through connection to a PC with DriveWizard Plus. With the new generation of drives comes a new generation of software. Enter DriveWizard Plus. The new and improved DriveWizard Plus currently supports the V1000 as well as the J1000, and will support the subsequent drives from the new generation. The 7th generation drives will continue to use DriveWizard 6.1 because there is no backward compatibility for DriveWizard Plus and the 7th generation drives. DriveWizard Plus has a new interface that offers many ways to customize your layout. The tools available within the new layout are new as well. There is also better trending and graphing of drive monitors with faster update times for serial connections. The tab-style layout makes it possible for the user to easily jump between different monitoring options such as graphical monitoring or spreadsheet monitoring. DriveWizard Plus allows the user to program a run routine for the drive to follow too. The program can be run once or continuously looped through. Notice that the J1000 requires the optional RS-232 board to connect to DriveWizard Plus. A J1000 drive software simulator is available on our website at yaskawa.com. The simulator is a program that will mimic operation of an actual J1000 drive. All of the keypad buttons that exist on the J1000 will be clickable on the simulator, which means that the virtual J1000 will be programmable just like the real drive. Both analog and digital inputs can be manipulated as well, and the analog and digital outputs are displayed so that their operation can be tracked. The simulator will even be able to replicate the operation of a loaded motor. The benefit of this free software is in the ability for users to test and troubleshoot J1000 operation without having an actual drive in front of them. It is also an excellent tool for teaching others how to use the J1000 drive. The software is available at www.yaskawa.com. A copy of the software will also ship with the drive on the product CD. Shown on this slide are other options for use with the J1000. Check yaskawa.com for release dates. This concludes my presentation of the proud new addition to the Yaskawa family of drive solutions. Thank you for viewing this Yaskawa Electric e-learning module. I hope that the information presented was informative and helpful. If you would like additional training, please contact us through any of the methods shown on this slide. Thanks again, and have a great day.